And welcome back to MCMT YouTube channel. Today we are going to launch Challenge 6. Challenge 6 is linked to one of our employers called T3DMC. This company is based in Shropshire and they are a 3D measurement company and are a UK leading supplier of 3D engineering solutions. They specialise in 3D measurement, quality inspection and reverse engineering. They work with customers across all industries, from automotive and aerospace to power generation and medical. To find out more about what they do, their web address is listed below. Here are some of the engineering sectors that they work in. As you can see, this is very, very broad. Their product range involves 3D measurement, quality inspection and reverse engineering. And as you can see, they make use of computer-aided design as part of that inspection process and lots of different software packaging. So the challenge for you today is based around the quality of measurement. We would like you to select a misused or broken product in and around the home and redesign or replicate a component to repair. So the first thing we'd like you to look at is source a particular product to work on. So you might look in and around the home at a range of different broken products. So here you can see there's a range of products in and around our home that are broken or in need of repair or replacement products. So here you've got a handle from a wardrobe where a part is missing. We've got a missing connection for a reflector on a bike. We've got a missing clip on a bike helmet. We've got a damaged photo frame, missing top or lid from a pen, classic example of a repair needed in and around the home. And then we've also got a missing spool from a tape dispenser. So we want you to explore different products and then we want you to select one to work with. The one that we're going to select to work on today is the spool for the tape dispenser, because that's our biggest bugbear when a product can't be used because of a missing component. So once you've selected your product, it's really important that you gather the data. So data and measure is really critical in engineering, and this is what this company specialises in. It's critical to get the measurements correct, especially if you're making a product of fit. As you're an engineer, you should now focus on at least working in millimetres. Centimetres just isn't going to cut it, because centimetres means that the size of the error, if an error is made, is far too large. So just to remind you of units of measure, a centimetre is equivalent to 10 millimetres. But engineers in industry work in micrometers and nanometers, so even finer measure. So to give you an idea of these units of measure, 1 millimetre is equivalent to 1,000 micrometers. And 1 micrometre is equivalent to 1,000 nanometers. So this is just good for you to understand. Now you may not have the measuring tools in and around the home, but you do need to be aware of the various units of measure that are used in engineering. So remember, make sure you're working to at least millimetres. Here are some examples of the measuring tools that are used in engineering to make sure that we're working with accuracy and precision. Now hopefully you've already started using a steel rule in your school environment to measure, and you'll notice that a steel rule, the zero starts from the end of the rule. And on this particular rule, as you can see, it's marked out in millimetres. But even a millimetre is quite a large error. So if you're working within engineering, within your school or college environment, you may have come across some of the other tools. If you haven't, we're just going to introduce you to them. So vernier calipers are a tool that are used commonly in engineering to measure both in millimetres and micrometers. So you can find that you can measure internal measurements, external measurements very easily with a lot more precision than a steel rule using vernier calipers. As you can see, there are two types of vernier calipers. You've got ones that are manual, where you have to read them yourself, or you've got digital ones. And the digital ones obviously provide a lot better accuracy for you as an engineer. The other type of product that you might use in engineering to measure is called a micrometer. And yes, you've guessed it, that's to help you read and measure micrometers. So the data that you need to get from your product, you need to look at your product and you need to gather key information. So what we've gathered from this particular product, we've looked at the product, but we've actually looked at the product that's going to go into that. So it's a tape dispenser. So we've not only measured the tape dispenser void and hole, but we've actually measured the tape itself. So we've measured the internal diameter of the tape, and you'll notice it's 77 millimeters. It's not 8 centimeters, we're working in millimeters. Had we have rounded it up and worked 8 centimeters, that error would have meant that the product wouldn't have fit. So we've measured the internal diameter, the external diameter, the internal radius of the tape to find the center point. So we've taken the diameter and divided it by 2. We've also measured the width of the tape. We've also measured the width of the inner part of the spool. We've also measured the width of the slot on the dispenser and the distance across the slots either side. So we've gathered some key data there. That has then allowed us to think about tolerances. Now, a tolerance in engineering means how much bigger or smaller a component can be compared to its original measurement. So we have measured those key core measurements for manufacturing the spool. But what the tolerance means is if my measurements are out by 0.1 millimetre, that spool will still fit in to the tape dispenser. If it's less than 0.1, again, it will fit in. So that's the tolerance. If my tolerance was plus 1 millimetre, that might not be, it may not work. The products might not fit if it's 1 millimetre too big. So a tolerance is the room for error. So something that you need to understand in engineering, especially when you are working in metrology, which is the area of measure, you need to understand tolerances. So have a little think about how much bigger or smaller could your product be for it to still fit. So once you've got the data and once you've considered the tolerances, you then need to make your repair. So we've used computer-aided design. We've used a software called Fusion 360 to manufacture this said product. So we've manufactured a very simple design for a spool, and as you can see to the right of it, we've produced an engineering drawing which can be done within that software as well. So we've already said the recommended software to use would be Fusion 360, which is free for education. If you're new to computer-aided design or you're younger, you might want to start using Tinkercad. But my recommendation, if you're at secondary level, to start using Fusion 360. So because we're so fortunate at MCMT, we have access to 3D printing facilities, all thanks to Shropshire 3D Print. So if when you've developed your idea on computer-aided design, you can send it to us here at the centre and we can get that manufactured for you so you can check if it actually fits your product. We hope you enjoy this project and we hope you enjoy exploring metrology. Thank you for listening. Goodbye.